Hello everyone, welcome to Anand Faiz Academy, and today we'll take a look at the binomial theorem from the series chapter of 4037 Additional Mathematics syllabus. So what does the syllabus statement say? 12.1 states to use the binomial theorem for the expansion of a plus b to the n for positive integer n. This includes the simplification of coefficients. The formula for the binomial theorem is given in the list of formulas. 12.2 states to use the general term n choose r, a to the n minus r times b to the r, where r is greater than 0 and less than n. For example, find the independent term of x in the expansion of 2x plus 1 over x whole to the 10. So now we will take a look at the lecture notes. Let's get started with the binomial theorem. To review, let's take a look at a simple math problem from the Mathematics D syllabus. What is the simplified version of 2x minus 5 to the whole squared? Well, the way we can solve this is by using the distributive law of two multiplicative terms. So we have 2x and minus 5, and then it's being multiplied by itself, since that's the meaning of the square. How can we solve this? We can spread the 2x out between the terms and also the minus 5 between the terms. So what we will get? What will we get? The 2x multiplied by 2x is 4x squared. The 2x multiplied by minus 5 is minus 10. And the minus 5 multiplied with 2x is minus 10. And minus 5 multiplied with itself is plus 25. And once we solve this, we get the final term, or the final version, 4x squared minus 20x plus 25. Okay, so that's the FOIL method, or the distributive law. Another way to do it is using the term a squared plus 2ab plus b squared. Okay, so here a is 2x, 2 is simply the constant over here. A is again 2x. B is here is 5. And b squared is 5 squared. We will actually use a squared minus 2ab since we have a minus sign over here. So once we solve this, we get this term. All right. How can we solve anything to the cube then? Okay, it's pretty easy. We simply do a plus b whole squared plus times a plus b. So we simply use a squared plus 2ab plus b squared. And then we use the FOIL method to distribute all of these terms throughout a and b. And what do we get? So a squared multiplied with a is a cubed, and a squared multiplied with b is a squared b. Then 2ab multiplied with a is 2a squared b, and then multiplied it with b is 2ab squared. Then b squared multiplied with a is ab squared, and then the final term is b cubed. Once we simplify this, we will get a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, now the cube and the square were pretty easy, but now let's deal with to the fourth powers. How can we do this? Well, we can divide it into squares, and then, yeah, we can use the FOIL method, but it will take a lot of time. How can we solve this in an easy and fast way? That's where the binomial theorem comes. So what does the binomial theorem say? The binomial theorem states that any a plus b to the n can be represented using this whole thing over here. Okay, before we get to that, let's take a look at a Pascal's triangle. Okay, now Pascal's triangle is a special type of number triangle or a number puzzle where each individual terms in the middle is added and the corner terms are just brought downwards. So we start with 1, we bring down the corner terms, which is 1, and then we add the two terms in the middle to get 2. Bring down the corner terms again, and then we get 1, 1. Bring down, add the middle parts to get 3. Bring down the corner parts to get 1. And if we repeat this, we will get a series of numbers. Okay, how is this related to the binomial theorem or anything? Take a look at the coefficients, okay? So here, our coefficients of a plus b whole cube is 1, 3, 3, 1. And a plus b to the fourth power is 1, 4, 6, 4, 1. Doesn't that look familiar? Yes, it's simply the terms in the Pascal's triangle. 1, 3, 3, 1. 1, 4, 6, 4, 1. So we can use the Pascal's triangle to find the coefficient of each term in an expansion. So a plus b to the 0 is 1. That's the first term in our Pascal's triangle. A plus b to the 1 is 1a plus 1b. A plus b whole squared is 1a squared plus 2ab plus 1b squared. And a plus b to the cube is 1, 3, 3, 1. I'm ignoring the terms because it will take time. A plus b to the 4 is 1, 4, 6, 4, 1. It's exactly corresponding to the Pascal's triangle. So if we want to expand anything a plus b to the n, we can use the Pascal's triangle. But not everyone is, well acquainted with the Pascal's triangle, and it might take a long time to draw it out. Okay. If anything a plus b, let's say a plus b to the 18 is given, we will have to draw 18 lines or 19 lines to actually get to that. So it'll be very time consuming. So how can we find the how can we find the coefficients of a binomial expansion without the use of Pascal's triangle? That's easy. We use the choose function. What is the choose function? It is simply a mathematical expression given by n factorial over r factorial times n minus r factorial. What does factorial mean? Factorial, let's say 4 factorial is simply given by 4 into 3 into 2 into 1. The product of each of the terms starting from itself up until 1. That is factorial. Now, what does choose really mean? Choose is a type of function which allows us to calculate the number of ways, let's say n objects can be picked from, r objects can be picked from n objects where order doesn't matter. So let's say I have 4 objects here. That is red, blue, green, and yellow. In how many ways can I pick 2 objects from these 4 objects? So first we can pick red, blue. Then we can pick red, green. Then we can pick red, yellow. Yes. And then we can pick blue, green, blue, yellow. And then finally we can pick green, yellow. I'm not picking blue, red because that's the same as red, blue since order doesn't matter. So how many different combinations did we find? We found 6. This can be easily calculated using the choose function by giving n objects 4 and the number of r objects to pick 2, and this will exactly give us 6. Now let's come to the binomial theorem's generalized formula. So the generalized formula for the binomial theorem of a plus b to the n is simply given by the first term raised to the highest power, then added with n choose 1, the first term raised to the n minus 1 power, and b raised to the first power, plus n choose 2, first term raised to the n minus 2th power, and b to the second power, all the way until we have the general term over here, n choose r, a to the n minus r, b to the r. This is the term that you need to remember for your exam. An easier way to remember, or another way to remember this, is using the sigma notation. Sigma notation simply means to add the sums up. Let's say that you have a here, so the I goes from, let's say, 0 to infinity. So a will go from a1 plus a2 plus a3 plus a4 all the way up until a infinity. So n, so here what we're simply adding are the NCR, a to the n minus r, b to the r terms, where r varies from 0 to n. Okay. Now we will take a look at another form of the binomial theorem, which involves no n choose terms, just simplified coefficients. So let's take a look. So we have 1 plus x to the 7 here. Once we simplify this in our binomial theorem, we get these terms. Okay. So then what we will do is we will simply write these terms in our n choose r formula. Write the coefficients using our n choose r formula. So we have here 7c1. So this is 7. That's That's a common thing to know. And then 7 choose 2 is simply 7 factorial over r factorial 2 factorial into 7 minus r factorial, or 7 minus 2 factorial. That is 7 factorial over 2 factorial into 5 factorial. We go on for the next two terms. Then what we do is we write out 7 factorial as 7 into 6 into 5 factorial. As we know that n factorial can be written as n into n minus 1 into n minus 2 factorial. Yeah, that's how we can write it. This is simply given by n factorial. Okay, then we write 7 factorial as 7 into 6 into 5 into 4 factorial. And the same thing goes for the other two terms, for the next term. An interesting thing happens. The 5 factorials get cancelled out. Here, the 4 factorials get cancelled out. And here, the 3 factorials get cancelled out. So what do we get? We get 7 into 6 over 2 factorial, 7 into 6 into 5 over 3 factorial, and 7 into 6 into 5 into 4 divided by 4 factorial. All right. So what does this mean? This means that for every n and n minus 2 term, we have to divide it by its 2 factorial term. So for n into n minus 1 into n minus 2, we divide it by 3 factorial. And for n minus 1 times n minus 2 times n minus 3 divided by 4 factorial, we have to divide it by 4 factorial. So this is our another generalized formula. We got it from this expression here. Now we will take a look at some exercises.